Hello everyone, in this video I'll be explaining you the problem method remove method from project. So you're maintaining a project that has n methods. Methods are basically in layman terms you can say functions, numbered from 0 to n minus 1. You are given two integers n and k and 2D integer array invocations where invocations of I is in the form a of I comma b of I, indicates that method a of I invokes method b of I. So it's a directed thing. Okay. There is a known bug in method K, and method K along with any method invoked by it, either directly or indirectly. So method K along with any method invoked by method it, in the sense method K, either directly or indirectly, are considered suspicious and we aim to remove them. A group of methods can only be removed if no method outside the group invokes any method within it. So don't worry, I'll tell you. So return an array containing all the remaining methods. After removing all the suspicious methods, you may return the answer in any order. If it is not possible to remove all the suspicious methods, none should be removed. Okay. So let's take this graph and try to understand. So the problem name is remove methods from project. Okay, so in the question, what they said is we need to remove methods from the project. So there are basically n methods. There are n methods numbered from 0 to n minus 1. Okay, and they've given method k, which is suspicious. Okay, so from method k, all other methods invoked are also suspicious. You're understanding, right? So it is basically a graph problem only. So I'll take one example. I'll tell you how it is. So what they're saying is from method k, let's say we have method k. From here, you know, we have, let's say, k plus 1 or something like this, k minus 1, and we can have, k plus 2, something like that, and it is connected. So from method k, either, directly, so this k plus 1 and k minus 1 are direct methods, or indirectly, this k plus 2 is also indirectly. This all form a suspicious group. Okay, suspicious group. And now let's say we have some methods like 1, 2, k minus 2 we can call, and let's say they are interconnected, something like that. Okay, and from this non-suspicious group, if any of the method from non-suspicious group, if it calls to any method in the suspicious group, then we can't remove this. Okay, and in case this non-suspicious group, any method, I mean all the methods, if it does not call any method of the suspicious group, then we can remove the suspicious groups. So at the end we are asked to, um, uh, at the end we need to return non-suspicious group, in case no method from it calls any suspicious method. Once I take example, it will be very clear. It's just a wording. Okay, we need to return non-suspicious group, and in case any method, let's say it calls to any non-suspicious method, it calls to any suspicious method. So in that case, you don't need to remove uh, suspicious group. In that case, you need to remove, return the entire nodes, entire methods. Return entire methods in case any non-suspicious method calls any suspicious method. Okay, so let's take one example and it will be very clear. So first example, let's take n is 4, k is 1, and invocations are 1 comma 2, 0 comma 1, and 3 comma 2. So they're saying we have four methods and it is numbered from 0 to n minus 1. Let's take 0, 1, 2, and 3. So four methods are there, and they're saying this method k1 is suspicious. Okay, and we have an invocation 1 comma 2, which means 1 is calling method 2, 0 to meaning 0 is calling 1, 3 comma 2 meaning 3 is calling 2. So this is a kind of a directed graph. It's a directed graph. So first thing first, we need to find the suspicious group. So how do you find suspicious group? So k is 1, so 1 is already a suspicious. So from 1 you have to find what all method it is calling. So as you can see, it is calling 2, so 2 is also suspicious. Okay, and directly it is calling just 2, it's a direct call. And if you see, we don't have any other direct call, and from the direct call methods, now you have to check what all it is calling. So 2 it is not calling, so we have suspicious groups as 1 comma 2. Okay, once we have suspicious group at 1 comma 2, now the remaining this is suspicious group, the remaining 0 comma 3 is it's a non-suspicious, it's a non-suspicious group, 0 comma 3. Now we need to check from 0 are we calling any of the suspicious group, suspicious method. So as you can see, 0 it is calling 1, so 0 it is calling 1. So if this is the case, then you can't you can't remove suspicious group. So in this case, we need to return the entire methods. So return entire method, it will be from 0 to n minus 1. So this thing will have to return. Now let's go to example 2. N is 5, k is 2, and invocations are 1 to 2, 0 to 2, 0 to 1, 3 to 4. So we have um, five methods. So we have 0, 1, 2, 3, 4 from 0 to n minus 1. And they've said k is equal to 2, which means method 2 is suspicious. Now invocations are, we have one method calling method 2, 0 is calling 2, and then 0 is calling 1 as well. Okay, 3 is calling 4. Now if you see, so 2 is a suspicious. Now if you take suspicious, we have 2, right? Sorry, it is not 2, it is 0. My bad. It is 0. So 0 is a suspicious. So as you can see, 0 is calling directly method 1. So 1 is also suspicious, and it is calling method 2. So 2 is also suspicious. And if you see 1, it is calling, method 2 indirectly. These two are, direct direct calls, and this is an indirect call. So since 1 is calling 2, so 2 is already present in suspicious group, so no more changes. So this is suspicious group, and non-suspicious group is gonna be 3 comma 4. Now we need to check if 3 is calling what. So 3 is just calling 4. It is calling just 4. Is it calling either 0, 1 or 2? No, it is not calling. So which means and also you can check for the 4. 4 is calling nothing. So as you can see, this group is separate from this group. So this group is actually suspicious, and this is non-suspicious, and they are both disjoint. They are separate. Since they are separate, so in this case you can completely remove the suspicious group, and you need to return the non-suspicious group, which is 3 comma 4. You need to return. Similarly goes out with example 3. So example 3 I'll take quickly. So this is example 3, and here k is 2. So this is suspicious. Now in the suspicious group we have 2, and 2 is calling 0. Okay, and it is not calling 1 directly, but indirectly 0 is calling 1. So this is suspicious, and if you see non-suspicious, so it is empty. We don't have any element. So in this case, what will happen is, since you don't have any non-suspicious, entire thing is suspicious, you can remove the entire thing, and you need to return just empty, uh, methods. So I think you guys have understood. Now how do we solve this? So it's pretty much like how we were solving. So what we need to do is, we need to, so from the given invocations, we need to first find edges, as least we can say. Okay. So once we form graph, this will basically form a graph. So once we form a graph, so what you need to do is we can do either BFS or DFS, but I'll be doing BFS. So do BFS from node K, or you can say method K, node K, and put all invocations you can say, or calls you can say, calls into suspicious group. Okay. Third step will be um, from all non-suspicious methods, check if these methods calls any of the suspicious method. Okay, so yeah, this is pretty much only the 3 lines. This will solve the problem. So first we need to find the edges from the invocation, because edges are in the form of a comma b, which indicates we have an edge from a to node b, right? This thing they're saying. So we need to make sure we'll find an edge list in order to improve the time complexity. And next thing, from the node k, since it is suspicious, so what all nodes can we can we call from the node k? So all that nodes will be put in a suspicious group. Okay, and we'll run a loop from from 0 to n minus 1. We'll run a loop and we'll check if a node is non-suspicious. Okay, if a node is non-suspicious, what we're going to do is we'll be checking from that node, can we call you know the suspicious node or not. So okay, how do we do that? I'll tell you here only. Like, let's take one example. So our edge list is gonna be, since your node is 4, so we have 0, 1, 2, 3. 3 nodes will be there, and 1 is calling 2, fine. 0 is calling 1, okay, and 3 is calling 2, and 2 is calling nothing. So as you can see, T does not have any outgoing edge. So this will be our edge list. And from the edge list, as you can see, our suspicious groups are 1 comma 2, right? As we can say, suspicious group is 1 comma 2. So this 1 and 2 is a suspicious nodes methods. So when we are running a loop, as I said here, we'll run a loop from 0 to n minus 1. So we'll figure out that 0th node is suspicious, so we'll not do anything. So we'll now figure out node 1. It is not suspicious. From node 1, what all we are calling, we'll check what all nodes we'll be calling. As you can see, 2 we are calling, and then since we'll be having a set of suspicious groups, so this particular node I'll be checking in this suspicious group if it is present or not. If it is present, that means there is a connection between suspicious group and non-suspicious group. Okay, so in that case, we have to return the entire you know no methods or nodes. Okay, similarly, what will happen is here you have 5 nodes, right? So let me just erase a bit. Okay, so we have 5 nodes, so 0, 1, 2, 3, 4. Now as you can see in equations, so from 1 we are calling 2, okay, from 0 we are calling 2, from 0 we are calling 1, and from 3 we are calling 4. So this is our edge list now. And as you know, our suspicious group is 0, 1, 2. So this is our suspicious, this is suspicious, this is suspicious. So we'll be running from loop from 0 to n minus 1. So these 3 will be suspicious, and we'll go to node 3. And node 3's edge will be checking how many neighbor nodes which we have from node 3. So we have 4 and 4 will be checking in suspicious group. So 4 is not present in suspicious group. So we'll move to node 4 now, next node. So next node does not have any neighbor nodes. So in this case, what will happen is we'll come to know there is no connection between suspicious group and non-suspicious group. So yeah, let's go to VS Code and solve this. So in order to find if it is suspicious or not from non-suspicious node, I'll be using set. So first thing first, what we'll do is we'll form edges. Okay, I think you guys know how to form the edges, so I'll be moving fast forward here. So we'll have two nodes. First is U and this is V. So since it is a directed graph, we'll be having a direction from U to V. So it will be edges of U dot pushback edges of V. Now we need to find the suspicious group. So we'll take unordered set. We'll call suspicious group and we'll call find suspicious and we'll pass k and we'll pass this as list. Okay, now let's find suspicious. We have node, we can say start node, and we have edges as well. Now what we're going to do, we'll be doing a BFS method. BFS method. Okay, so first we'll take visited vector of size n. So n is going to be edges dot size. Okay, and for visited of start node, we'll mark it as true. Now we'll have q, and in the queue we'll be pushing the starting node, which is start node, which is kth node, kth method we can say. Okay, once we have these two things, we'll take one more unordered set, and since this is suspicious group you can say, and in suspicious group the initial node is always the kth node, right, which is start node. So once we have these things, I'm doing a BFS method. While queue is not empty, now I'll take suspicious node q dot front and I'll remove that node, and from that particular suspicious node I'll be taking neighbor node, and it will be edges of suspicious node, and before inserting into our queue we need to check if the visited of neighbor node is false. If it is false, then we will be inserting into first queue. We'll be inserting into suspicious group and we'll be marking it as visited. So once we come out of this loop, we'll have to return this suspicious group. Okay, so at this position we have suspicious nodes. Now we'll take one variable, um, remove sus group. First we'll mark it as true, like we'll be checking here, we'll be writing a logic to check can we remove a suspicious group or not. First we are saying we can remove, but later we will have to find a connection between non-suspicious group and suspicious group. If we find a connection, then the suspicious group remove will be a false. Okay, so as I said, I'll be taking a for loop node. We'll be moving from node 0 to n minus 1. Now we'll be checking if this node, particular node belongs to suspicious group, then it is a suspicious group. So we have to check a connection between non-suspicious group. Okay, so for that we have to check if this node is not present in suspicious group. So dot count of node, if it is 0, which means it is not present in suspicious group. So it's a non-suspicious node. If it is a non-suspicious node, what did I say? We have to check its edges. Now we'll be checking its edges. We can call neighbor nodes, neighbor node of edges of suspicious, we can call node. Okay, it is a suspicious node. And since we have neighbor nodes, and we need to check one by one this neighbor node if it belongs to any of the suspicious group, which means we can't remove suspicious group. So here what will happen is we'll have to check if the suspicious group dot count has a node. If it has a node, then we can't remove the suspicious. So suspicious removal will be false, and we need to just break it up. Like if we just find at least one group, so yeah, we can't do it. Then once we have found a single connection, so it will be false. Uh, then you need to compute. I mean, don't need to compute. So just come out of the loop. Now here we'll take vector as answer. Now we have to check if this remove suspicious group is true, which means we have to remove the suspicious group. Okay, if it is false, then we have other thing. So if it is remove, so let's remove the suspicious group. So how do we remove? We'll start a node from 0 to n minus 1. Okay, and we'll be checking if this particular node belongs to suspicious group, so you have to remove. Okay, if it belongs to particular group, suspicious group, we have to remove. So by removing, we mean from the answer we have to remove. So if it does not belongs to suspicious group, it means we have to add into answer. Okay, so it does not belong to suspicious group, we are adding to answer. And once we come out of this for loop, we have to return the answer. And in case the suspicious group removal is false, like we should not remove suspicious group, so in that case we need to put in all the nodes. I mean, we have to return all the nodes. So answer dot pushback, it is going to be node. We have to return this answer. Let's try to run it. Hmm, edges, you pushback dot edges of, sorry, it should be v, it should not be edges of v, it should be v, like we are pushing the node v. And sus group, okay, it should be dot count, which means this particular node is not present in suspicious group, so it will be a part of our answer. And okay, we have defined vector answer here, so one more time we don't need to define, remove this. Okay, my bad. This answer should be returned in here. Um, okay, this entire thing has to be, I mean, yeah, this thing we are missing. Not a big deal. So it is running. Let's try to submit. So yeah, it got accepted. So basically, it's an you know medium problem, I'd say. Just you have to do BFS. So in order to BFS, you'll have to calculate the edges. Okay, edges you'll have to calculate, and then you have to do BFS. So this is a BFS code starting from node K. Once we have suspicious group, we'll have to take non-suspicious group and find if there is a connection between non-suspicious and suspicious. If there is a connection, so remove that suspicious group. If there is no connection, so just return entire uh, nodes. So that's it. So thank you guys for watching the video.